Hi everyone and welcome to this new video of Data Science at Scale with VerticaPy. It's Bader speaking. In this video we will solve a very interesting use case, credit card fraud detection. Many frauds are happening every day and criminals are always innovating to get new victims. Most of the times they steal the credit card's information to make a lot of online purchases. They can only be detected when the victim notices some unusual buying in his bank account. How to catch them? What are the different types of credit card frauds? Why is it important to have all the data centralized in one place to be able to catch them? Should you use real-time or near real-time analytics? We will answer to those questions and even more. But first, what are fraud detection models? Frauds are outliers of a distribution. Machine learning can be used to detect them. There are multi-types of frauds like stolen cards, phishing, or hacking. In all cases, the credit card information is used to extort money. Later, we will see more deeply the two last concepts, phishing and hacking. As you can notice, we can gather the different frauds into two categories, card present fraud and card not present fraud. For the first one, the card is physically stolen. The thief will try to extort the maximum possible amount, but he has a limited room to maneuver. Stolen cards can be reported quickly by cardholders. Whereas for the second case, the compromised account details may be held by a fraudster for months before any robbery, making it difficult to identify the source of the compromise. The cardholder may not discover fraudulent use until receiving a statement. An example is phishing. To explain it, let's consider the following example. A mail is sent to many computers. Fraudsters are trying to reach as many people as they can, until they find someone who will click on the link. The mail will lead the receiver to a web page where he will have to enter his information in order to win some goods. The fraudster can then keep the information in order to steal money, until the victim figures out he was tracked. But it is then too late. He will have to inform his bank to block the card and he will have to see if he has an insurance for these crimes. Credit card hacking is also very common. It is very hard to catch as the user is not directly the victim. Nowadays, we are more and more spending money online. We visit a shop webpage and order goods using our credit card. Our information are then stored in a server. If the information are not encoded, a malicious user can easily reach them and steal money. That's why it's very important to look if the web page is secure. Companies have no right of storing our credit card's information. They must encode them first to follow GDPR rules. Otherwise, the worst can happen. Without machine learning, the credit card fraud becomes very hard to catch and any malicious user can take advantage of the system. The security can differ depending on the transaction's amount. It can either need a code or not. The credit limit can also differ. The fraudster will have a limited number of attempts. Let's draw the money gauge to illustrate the example. The higher it is, the more the fraudster will extort money, and the excitement meter to illustrate his reaction to the transaction. The first operation is a card present fraud. In a bank, he will try multiple withdrawals. The security is high, so he can try to steal many medium amounts. And it will probably work most of the time, until he reached the card ceiling. He can continue his purchases in many shops. He can then try some high amounts. When going to shopping, the security is not really high. He can then enjoy stealing the maximum he can, and go to smaller amounts where there is less security. He can also do some contactless payments. With small amounts, he can then continue extorting more and more money and switch to the web. This time it is a card not present fraud. He can make multiple attempts on high amounts and smaller ones. Wow, jackpot. The fraudster took everything he could. It will be difficult to get back all this loss. We can see the happiness in his eyes. But what will happen when using machine learning? We can maybe get a successful attempt. A bank cannot detect the first suspicious withdrawal except if the amount is really high. But he will not make it further. He will not succeed buying expensive goods in shops. Maybe some very cheap ones, but not too many times. For the web, it will be very easy to catch him. At the end, the loss will be very small. The bank will most of the time reimburse it. We saw in the last video on outliers detection how to catch them. The easiest way to detect frauds is to use rules and thresholds. They are very easy to deploy and they have a low complexity. However, they can only detect global outliers and they are most of the times underfitting. These techniques are very good to identify card-present fraud. Supervised techniques have many advantages. The number of techniques is very high and we have many ways to test them. They are most of the time easy to deploy and they allow real data-driven experience. However, supervised learning can only be used when we have training data and tend to overfit when dealing with fraud detection. They can be used to identify card-not-present frauds. The only techniques which can find all the different kinds of frauds are unsupervised learning. They allow finding contextual and global outliers, but there are no ways of testing the model score and sometimes unsupervised models can be very hard to deploy elsewhere. They can be used to identify card-not-present fraud. Some other techniques like decomposition can also help detecting frauds. They have a low complexity and can be used to find frauds on unstructured data. They can be used on surveillance cameras to identify a fraudulent action and block a card-present transaction. However, there are no way to test the accuracy of a model. Different use cases have different requirements and different time constraints. We will cover more deeply the difference between near real-time and real-time in another video. But let's see how to proceed for this use case. Let's consider the following ATM. There are simple rules that we can implement directly inside the machine. For example, if the amount of a transaction is high, the machine can do some computations. No need to query the database. The amount is too much high. It can reject the operation. We are doing real-time analytics. However, if the amount seems to be reasonable, the machine can query the database. It can be an MPP columnar database like Vertica, where all the data are well organized. We can follow the data following GDPR rules. Use in-database machine learning and analytics to do the scoring. And compute all the predictions. This is what we call near real-time. It will take few seconds to send back the prediction and catch the fraud. Depending if we want a real-time or near real-time operation, we can decide to do in-database scoring or to export the model. Everything can be easily done thanks to Vertica. Now that we know the difference between real-time and near real-time, what are the features we can create to catch fraud? The most interesting features are built using moving windows. Let's consider the following sequence. We can see one transaction at regular interval of time. But if for a small interval of time there are too many transactions, they are possibly suspicious. Moving windows will directly count them. Another interesting feature is the elapsed time. If the elapsed time between two transactions is low, it can be considered as suspicious. Not only time can be used to build feature, the transaction amount can also be a solution. We can use ZSCORES to detect outliers. When a transaction is much higher than the cardholder distribution, it is possibly fraudulent. The Z-score can be used to identify it. The standard deviation can also be used. In this case, we can identify multiple similar transactions during a small time interval. The standard deviation or IQ error will be then near to zero. All those features can easily be built using VerticaPy. Moving windows and the elapsed time since the last transaction can only be computed when having access to historical data. We can use them for near real-time use cases. For the Z-score and standard deviation, they can be computed in advance and be cached into the system. It can be used for a real-time use case. However, it is preferable to do near real-time analytics for fraud detection, as historical data are essential to build interesting features. Wow, we learned a lot. To understand more deeply the use case, it is important to do some hands-on. We will use Jupyter and VerticaPy to create a credit card fraud model. We will see how. Creating a database connection, ingesting a dataset, preparing relevant features, creating a machine learning models and evaluating it. Let's go. Let's use Jupyter to illustrate this topic. You can click on the link to download the dataset in Kaggle. Let's import the VerticaPy package and its SQL extension. In VerticaPy, it is possible to work both in SQL and Python. All the computations are pushed to Vertica. If you did not create a permanent connection, those lines of code will allow to save a credential in VerticaPy directory. They will be used to create connectors when it is needed. Be sure to have the same or an upper version to avoid compatibility issues. For this use case, let's create a new schema. We will name it Credit Card Fraud. We can ingest the dataset using readCSV. It will use flex table to identify the different data types and store the dataset in the Vertica database. This dataset includes many transactions and we have access to the credit card ID, the date of the transaction, the amount, and if the transaction is a fraud. The dataset includes more than 11,000 transactions, of which more than 5% are frauds. Transactions are between $1 and $3,000. The dataset is really unbalanced. We have to be careful when testing our model. Accuracy, for example, will not be a good metric. If the model predicts all the time that the transaction is not fraudulent, it will get a score of 95%, whereas it has no predictive power. We can build many interesting features. As there is a chronology and we have access to an ID, a date, and an amount, an ID is to compute the Z-score for the different credit cards. We can also compute the number of seconds elapsed since the last transaction. If it is the first transaction, we can impute the value using plus infinity, which is represented by the maximum value. Extracting the hour of the day can also be a good idea. We can expect that many fraudulent transactions will happen at specific time. Let's now create very interesting features. We can use moving windows to count the number of transactions and its average amount in the last 30 minutes, hour. Moving windows are very interesting features which can catch relevant temporal information. We are looking just before the operation, how many times the card was used, and what was the average amount. Let's now compute the correlation between the response and all the features. As it is a binary feature against a numerical, we can use biserial point. Wow! Features seems to be very relevant for the predictions. The number of transactions in the last 30 minutes 1 hour, and the number of seconds elapsed since the last transaction. We can verify the significance of the coefficients. The first one is significant. The second one also, as there is a natural high correlation between the 30 minutes and 1 hour windows. Let's just consider only the 30 minutes window features for the next steps. We don't need to add bias in our model. Let's create a machine learning model. Let's convert the response to integer. Import the Random Forest Classifier and seed the randomness. It is needed to get the same notebook results. Be careful when seeding the randomness in the context of big data. MPP columnar databases like Vertica don't like indexes. They will slow down the operations. We can then split our data into train and test. Create random forest object with customized parameters. We are also providing a name to the object as it will be stored in the database. Feed the model and compute the AUC. Wow, we have an AUC of 88.5% for our first shot. It is not bad at all. We want to maximize the true positive without sending too many false alerts. The AUC is showing us the flexibility we have. The feature importance is showing us which features are important to make the prediction. We can notice that the moving window and the Z-score seem to be the most important ones. It makes sense as Z-score will catch global outliers for each cardholder and the moving window collective and contextual outliers, where the fraudster can try to make multiple small transactions. To maximize our confusion matrix, we can look at the cutoff curve. The cutoff is important when dealing with classification. It is the threshold used to label the data as fraudulent. For example, taking a cutoff of 4.5%, we will consider any operation greater than 4.5% as a fraud. We can look at the confusion matrix and notice that we are catching most of the transactions, 154 over 204, by making 221 false alerts over the 3,500 regular transactions. It is not bad at all. We can do better by doing hyperparameters optimization or by building some other features. By reducing the cutoff, we will increase the number of false alerts but catch more frauds. We have to pick the cutoff that will be significant for business. In our case, we need to do near real-time analytics as our features are built on historical data. But it is possible to cache them and do real-time analytics. In order to do it, we need to export our model to independent Python code. The VerticaPy function to Python will help to export our models. VerticaPy allows to really simplify the entire data science process and to solve very complex use cases. We can do near real-time analytics using a user-friendly syntax. No need to move the data out and to think about how to deploy a model into production. That's just magic. Thank you for watching this video. If you liked it, subscribe to the VerticaPy channel in LinkedIn. Visit our GitHub page and add a star to a project. Learn more by visiting our website at vertica.com/python. You can also subscribe to our YouTube channel. See you soon for another video.